want to talk today about the Enigma machine. So what happens is somebody will throw something out, and then I will instantly become obsessed with it, think about it, create some ideas, and then see what everybody else did. 9 times out of 10, what everybody else did was significantly more complex and make something larger, right? So here's the Enigma machine. Oh, and by the way, so while I do this, I have, for example, a drawing that I created, and the so what I'll do is I will load the drawing and this image right here, because this is a wonderful image. I will load them both into Satoshi Vision, right, so that you can see and I can do things like I can load text, movies, PDF, whatever into Satoshi Vision. But for now, I'm just going to load Enigma and the image. And so, if this ever becomes an idea that we want to move forward with, then, like all those folks in East Texas, all those patent lawyers that buy up patents from people that create a patent a week or something, could attack me, get all the money, and feel really great about themselves, right? But aha, we have subverted the process because I've loaded this stuff into Satoshi Vision. I can show up into East Texas and go before the judge, say, "Take it to court now. Let's go, court. Let's do it." And that would not be what they're expecting, right? They would be expecting me to simply pay them off or whatever. The upshoot of this is I believe that the patent process is broken, right? The patent process is way broken. And it doesn't favor actual progress 9 times out of 10, okay? So I'm going to show you a bunch of different things here. So first of all, this is the Enigma machine. I just watched a couple videos about it. I'd watched one before. So the problem with the Enigma machine was that you had a cable that would say, "Oh, this is a nice big image." Okay, so the cable comes from like R to G and G to R, right? And so, or let's say S to Y. Okay, so when you hit the S button here, power comes from here to here, and eventually, and it comes to this set of wheels back here, right? Which gets calibrated for different things as well. So you look at there's little dials and cranks and stuff. And then there's wheels inside here. So as far as I can tell, the rotary dials back here weren't part of the bug, the vulnerability. It entirely lay in the fact that down here, you have to take a wire and take a cable and cable from here to here. Let's say on this day you're going to go from D to V and V to D. So and you can never cable D to itself, right? That was the problem, is that a letter could never represent itself, and therefore by having the larger machine, you could calculate backwards and figure and crack the message that day before they change the message the next day. All based on the fact that a letter can never represent itself. So obviously, a letter needs to represent itself, right? So that was what was created with Typex. So we're going to save this image as what's called Enigma machine, right? So now I'm going to come here, and I'm going to browse file from my device. There's Enigma machine. Open, upload. Hopefully this works. Sometimes things don't work, but you still get the idea. Yeah, okay, so got the name, the address, and it's a cool looking image here. So I think this is going to work. Yeah, this is just kind of how I show, can visually see if the file it looks like it's pretty much in the right direction. There's the op return message right there. This is a format message. I'm going to give it a shot. Hopefully we have enough money. it's kind of a large image, so I don't know how much that is, but it's not too much. It's like $1 or $2, right? So we're going to send. It did work because I see my result. So now that image of the Enigma machine is loaded onto the ledger. So if I broke a copyright there, sorry. I guess whoever owns this image can come get me. Now let's talk about my image, right? So let's get that one up to the situation. And my image that I created was, now it's interesting, I added, so each time I do this, if I use this address here, a tiny bit of the transaction actually comes to my laptop here, or it gets registered that way in the ledger, right? So that's a way that I'm actually, as I do this, I'm uh, uh, tying two different accounts to each other, which is just kind of an oddity. So let's see. Oh, I pushed the wrong button. Okay, so I want to go find my my scan. So hopefully I can find that in a fairly fast. Documents. The slowest part of this is always me working through the GUI here. Photos is under photos, maybe. Pictures. There it is. There it is. Scam 21. Okay. So now I'm just going to describe this, and I'm going to upload it. And then this video, if this video goes away, that's okay. But this will be out on the blockchain. And then if somebody is working on this patent for this right now, and they're going to win some sort of something that's going to, in the end, help us all, more power to you, but this is what I'm doing. All right, so there's the image, and I'm going to open it up. Now I'm going to explain the image as I upload it in this video. So let's do that because I can see it right on the screen. Right, there's the image, and interesting. Now this image is much smaller, right? But so let me explain it. Okay, so you remember looking at the Enigma machine, and what I said was that the problem was in the cabling, right? That you had to cable one letter to another letter, and thus the letter could never represent itself because you could never cable it to itself. And so that was the bug which Turing and his team were able to exploit to crack the code, right? So then they created the Typex machine, Typex, which was going to not have that exploit. So how do you do that? Well, there might be a really elegant way to slightly change the machine in order to do that, which I would call the hack. So if you can find a hack, you can hack the system and get rid of that exploit. The other thing you can do is you can engineer a solution, which is what 10 times out of 10 happens, because that's what you get funding for. That's what seems reasonable to everybody. It ends up working, but in the case of Typex, it created a machine that was significantly larger, so large, in fact, that it couldn't even go into the field in the way that the Enigma machine could. So while it was a better machine, it wasn't as elegant a solution. And the engineering way is immediately obvious. It's immediately obvious is that you don't plug A to P, you have a second register, and so you plug your cable from one register to another. But in this world of physical cables and wires and everything, you're making something that you're doubling at least, probably tripling the level of complexity right off the bat. Right off the bat. So if you can find that hack, and convince people to do that. And usually it's not possible. So the hacker type has to see the problem and then go solve it on their own in isolation. Because if they're found out, the troops will be rounded up and they will be stopped, fired, whatever it takes to get them to because look, once you got funding, you're on a track to do something, and you don't want some guy saying that maybe there was an easier way, especially 6 months into the project. You don't want some guy, especially if he said 6 months ago there's an easier way, and now you realize this thing's not going to go out into the field. You're going to have to tell the generals that. They were thinking that they were going to get something that looks just, I guarantee, absolutely, positively, 100%, all the generals, all the politicians, all the people that gave the engineers the money thought what they were going to get was something the size of the Enigma machine that didn't have the bug, right? And I bet many people realized that wasn't going to be the case and decided not to tell them. I'm guessing. Maybe I'm wrong, but I'm guessing. So you make the machine at least twice as big by cabling from here to here. But what you get then is the ability to cable W to W, if that's what you want to do. And then so you can't count on a letter never representing itself, and then it's not hackable, right? So they fixed the bug at, I would say, great cost. And now what's the hack? Well, so the hack, I said, was, well, you just have a capacitor. So you push the key and you take your finger off, and that is stored in a register somehow, in a capacitor. So now all the circuits are available to you, right? Everything is equal. You don't have one thing that's excluded because it's impossible that it could be this, because the wire has to come from here to here, right? So that's what I said, capacitor. Well, capacitors hadn't been invented yet, of course. It's part of the problem. So then I would say, okay, how can we create a crude capacitor? And I would do that with something like this. This would be the crude capacitor I would have suggested. Been shot down, and the project would have been a success without this years later, right? I'm guessing. I'm just speculating. So instead of having all of this, what you do is you have something more like a typewriter, where when you hit W, you have right here, you have something that pops up, and what it slides. These are like little BBs. When I was a kid, I had a BB gun, right? So these are BBs that are, and of course this is sideways, but these are BBs in a tube, and you have an arm, and what you do is when you calibrate the machine, instead of putting a wire from here to here, you calibrate the length of these arms, somewhat like a lock, and then this arm goes and it puts these pellets into position, and then when you remove it, right, then that acts. Then you create a circuit that has that coded into these pellets. And I'm saying there's 4 of them because just using bit logic, 4 by 4, that's plenty for all your characters that you need, right? So like a lock, it puts the pellets in a certain situation, and then this becomes like a capacitor, although you're not storing data, or you're not storing, a voltage. You're representing things. It's almost like maybe an abacus even, right? And you could have these little dashes here represent circuits that could potentially be made. Something like that. That's how I see this going. But the key is that I think that there's a way to do this where this part is a simple system. This part up here at the top didn't need to change at all. It was just with the wiring. So that's what I call the Typex hack. And now I'm going to put this into Satoshi Vision, so then that you see, and I could put text in there. I could load this little video up if I really wanted to for some amount of money. But this is very cheap to do, and I'm showing you a number of things at once. It's just an idea about the Typex hack. Absolutely, this is time stamped, but it's much more because you're loading these images up, right? And then I could go on to Twitch.app, and I could put it into there where different people that are Satoshi Vision aficionados could have a discussion about it or whatever. So I'm going to try to fund this. Hopefully it works. It's a bit embarrassing when I do this stuff and it fails. See, this one is because it's a smaller image. This one is cheaper. This is very inexpensive. I could see how much that is. But now, in the Bitcoin that everybody loves to hate, first of all, this isn't possible. If it was possible, it would cost like $40 or something. But this probably is like, I don't know, 50, 60 cents. Nothing. This is nothing. So I'm going to send, and this goes in there too. And then this should redirect to what's on chain. Oh, I don't redirect to what's on chain here. So I pulled the transaction back out. I click on what's on chain here, and there's probably somebody out there that's staring at this thing. What that is. See, there it is. It's right there. IBM Apple Image Capture, because I just uploaded it. I scanned it. And there it is. It's right there. It's right there. So this subverts, the patent process. It subverts the patent process. Oh, John, why would you want to do that? Because it doesn't work right. It's not helping us. It's not helping me. It's not helping most people. And what we need to do right now is do useful things that help people, not things that increase somebody's personal level of status. Okay. Yes, you've got to figure out how to get paid, but I think we can all figure out how to get paid by creating real things. I think the notion of even in the world of software, the notion of creating a software and then charging a renter, you become a rentier. I remember when Microsoft Word, you could buy it outright, or you could of course now you can use LibreOffice, but Microsoft works really hard to break the standards. So anything you create with LibreOffice is going to be questionable. So you might as well just pay for Word, because Microsoft doesn't have enough of your money already. Anyway, so I hope you enjoyed it. That's my Typex hacks. Hey, let's see if it's on any of these are on Crypto Graffiti, which pulls directly from this guy's out of Estonia, and this pulls directly from the memory cache. So it should be, see, there it is, right there. It shows up on Crypto Graffiti, right there. And there's 5 people running Crypto Graffiti. See, look at that. They're both there. Right? So, the solution that I've got has 2 pieces, right? I have something similar to Crypto Graffiti that gives you different search capabilities and supports things other than just JPEG images. If one of these had been a PNG image, it wouldn't show up. However, Crypto Graffiti is awesome. Like I say, just like what's on chain, it's this other thing outside where when you share this data, it's automatically there. Right? So somebody's looking at that, and it's not going to make a lot of sense to them, but maybe, you never know. Anyway, I hope you enjoyed this.